All right, so continuing on with Unit 7, we're looking at, once again, variables, independent and dependent variables, and we look at how we can create a graphing chart. Generally, when we do these, we're going to be looking at simply the quadrant 1, which is the top right, where I can graph a positive, positive. But our goal, once again, looking at what we want to be able to do, our objective for this lesson, is to be able to take a relationship and graph it so that I know that I have equivalent amounts as we go along according to the math that's given. I also want to be able to create that equation if I have the graph and be able to figure out mathematically what has taken place. So when I look at this example of y is equal to 2x plus 500, then I want to be able to take that and then so I want to take this equation and apply it to this graph of the x and y axis. Once again, I'm looking for coordinates or ordered pairs to be able to graph them. And they have to go in the order of x and y. Now, they're nice and they're telling us that our independent variable, the x, is in the math problem multiplied by 2, which is going to be a constant, plus 500, which is going to be a constant. But then the y is going to be the answer. And that's always going to be once I do the math. So if I take this equation and I plug in the x number each and every time, I can simply solve for the y. So in this scenario, I would take y is equal to 2 times 0 plus 500. And 2 times 0 is 0, so plus 500. That just means that y is equal to 500 in this example when I get my dependent variable for y. So then I get an ordered pair that if my x is 0, plugging it in there in the purple for my independent variable, then I do the math and I find out that y is simply equal to 500. So my ordered pair then would be 0 and 500. I just simply carry it over, making sure that my independent variable is on my x-axis because that's what I'm doing the math with. And my dependent variable is my outcome, it's my output, it's my answer, and that's going to be on my y-axis. So then as I continue on and I start looking at my independent variable there in the purple, then I just plug it in each and every time to that rule or that relationship, the y is equal to 2x plus 500. So in place of the x, I'm going to put a 1. Now I have 2 times 1, well, 2 times 1 is 2, plus 500. So I know that my y has to be 500 too if my x is equal to 1. I continue on with the same relationship, and this time I'm going to use my 2 as my independent variable because that follows the next process. So now I plug in with the 2, and I have that y is equal to 2 times 2 plus 500. Well, 2 times 2 is 4 plus the 500, so I know that my y in that scenario is going to be 504. So I forgot to mention my previous ordered pair, and that's why I got off. But when I have 1 as my x-axis, then my y has to be 500 too. If I have 2 on my x-axis, then I have to go up to 504. So in the same way, I'm going to do the same thing with the 3. I'm going to plug it in to my math equation where the x is, because that's my independent variable. And I'm going to have 2 times 3. Well, 2 times 3 is 6, plus the 500, that constant. So I find out that if my x is 3, then my y is equal to 506. So then I end up with an ordered pair of 3 and 506. Now, when we graph them then, we go back to that same pattern. I'm going to run, and then I'm going to jump. My first number is always going to tell me to run forward or backwards. Forward if it's positive, backwards if it's negative. Well, once again, these are going to be in my quadrant 1, so they're always going to be moving forward. But notice on this graph, this is something new for us. They got this little weird squiggly line. And this little weird squiggly line is just simply saying that if I had 0, then I wouldn't have anything, but my very first value at 0 is 500. So I'm automatically starting with 500, and then I'm just increasing by 2s as we go. So that little squiggly line on the y-axis is just saying that that's going to cover from 1 to 499 because we're going to skip all those numbers. So don't let that confuse you. So let's look at the first example in which they give us. says the equation A is equal to 126b. Now, once again, that is a coefficient touching a variable, which means multiplication. But that is the equation, that is the rule, that is the sequence that I'm going to use each and every time. And therefore, when I'm looking at it, then to begin this, I have to be able to identify which one is my independent variable, because once again, the independent is going to be the x on my coordinate plane, and which is going to be the dependent, which is going to be the output or the answer. And that's always going to be my y on my coordinate plane. So as I start looking at the math problem, the equation that I'm given, a is equal to, and I have 126b, then that's multiplication. That's what I'm doing my math with. So 126b has to be my independent variable. My dependent, once again, is always going to be my answer, my outcome, my output. So that's going to be an A. So I'm simply going to take that equation. I'm going to plug in my three options for my independent variables. The first one they give me is 0. So I'm going to plug it in. I'm going to have y, or that A, is equal to 126 times 0. Well, identity rules for 0 is any number times 0 is 0. Therefore, I have y is equal to 0. Easy enough. My next independent variable they give me is 1. So now I'm going to multiply by 1. Identity property of multiplication of 1. Any number times 1 is going to be that number. So 126 times 1 is simply y is equal to 126. Or in this case, the A is equal to 126. Now I'm going to plug in with 2. Now I have y is equal to 126 times 2. Well, when I multiply 126 times 2, I get 252. So I have y is equal to 252. So my third output, or my third dependent variable, when I have 2 as my independent variable, is equal to 252. Once I have that information, then I have to make them into ordered pairs. And once again, my independent is going to be my x, my dependent is going to be my y. Notice they show you the ordered pairs in the order of BA. So I'm going to take and carry that information over and create the 0, 0 for my ordered pair. So if I know that I have 0 as my B, then my A has to be 0. Or my X is 0, my Y is 0. If my B is 1, we know that my next number, my Y or my A, is 126. And then my third one using 2, we said was 252. So now I have my ordered pairs. And then my ordered pairs, once again, I'm simply going to graph. So once again, the pattern is I'm going to run and jump. Since it's in quadrant 1, I'm going to have all positive numbers. I'm going to run forward every time, and then I'm going to jump up. So 0, 0 is pretty easy. It just starts down there in the bottom left-hand corner. I don't go anywhere. On the next one then, it says 1 and 126. So I have to run forward to 1, and then I have to jump up to 126. Now, these are not exact numbers, right? These are just going to be approximate where about 126 might be. And then my third order pair is 2, 252. So I have to start at 0, 0, run forward to the 2, and then I have to jump up to 252. Once again, it's just an approximate area where it might be. Once I have my points plotted that I'm given, then I'm just going to show the arrow, which indicates the relationship. So it's an arrow because I have, or array, if you will, because I have an endpoint at the very beginning of 0, 0, and then the arrow head goes on, telling me that that would continue on in that pattern, showing the representation of the relationship until I run out of numbers. Right? Well, hopefully you're not finding this too difficult. Right? The goal is to make it as easy as possible. So let's do this check together. I have C is equal to 2P plus 3. They tell me that my total cost is represented by the C. All right. And then I'm going to plug in information for the P, which is going to represent pounds. Now, they don't give me a whole bunch of numbers to use, and that's okay. As long as I can set up my chart of independent versus dependent, I know my independent is what I'm doing the math with, so that's my P. My dependent is my answer, so that's my C. And then I'm just going to start plugging in some numbers. So if I use this equation, I can start with 0, I can start with 1, I can start with 2. So let's just start with 1. Let's say that C is equal to we're going to make P equal to 1. So 2 times 1 plus 3. Well, 2 times 1 is 2 plus 3. Then I know that my C has to be equal to 5. So I'm going to put 5 in my dependent variable. Well, same thing, but now instead of having the P, now I want to use the 2. Right? So if I go forward to the 2, how far up do I have to go? So my D independent variable is 2. I have C is equal to 2 times 2, which is 4, plus 3. So therefore the C, my dependent variable, is going to be equal to 7. I always like to do 3 of them, so let's do at least 3. So now we're going to plug in, instead of the P, once again, as my independent variable, we're going to plug in a 3. So now I have C is equal to 2 times 3, and that's 6, plus a 3. So in that situation, C is equal to 9. So now I have my chart filled out for 1, 2, and 3 in my independent variables, and their outcomes or their outputs, their answers, in my dependent variables. Now I have to make them ordered pairs, and that's pretty easy because I make sure that I set up my original charts in the correct order they're supposed to go. So my P versus my C, that means it's just going to be my X versus my Y, where X is on the left and Y is on the right. And therefore, when I make my ordered pairs, remember, ordered pairs is going to be an X followed by a Y, separated by a comma, and have parentheses at the beginning and end. So I have 1, 5, 2, 7, and 3, 9. That tells me my ordered pairs, but it tells me now I need to plot them. So let's plot them. So my first ordered pair is 1, 5. So I'm going to go over to the 1, right? So we're going to run, and then I want to jump up to the 5. My second ordered pair tells me to run forward to the 2, and then jump up to the 7. And then my final one says to run over to the 3, and then jump up to the 9. Notice that they make a nice diagonal line, and I want to show that relationship on my graph by drawing the ray. I want to make the line with the arrow going up and over out of the graph because it shows me that if I continue this equation, I will continue the same type of process and get an equivalent amount of steps as we go along. Now, there are times that we're given the graph and they want us to then interpret what the graph is saying to come up with the equation, right? So this is kind of like the reverse process as we just did. So when I'm looking at what's happening here, I can see going across the bottom my years of growth, and it's counting by 1, 2, 3. So that has to be my independent variable, where then the outcome, the output, the answer is going to be my height for each of those years. And therefore, that has to be my dependent variable. So as I'm identifying those, then I should be able to use some logic and math to come up with what the equations would be. So as I'm looking at it, and I just plug in the information that I know, I can see that I have 1 and 42 when it comes to my first set of ordered pairs. So my independent variable is going to be 1, and my dependent, or my height, is going to be 42. Now they go ahead and they tell us that these are where the points are for our ordered pairs, and therefore if I just simply separate them by the G and the H for my independent versus my dependent, then that already sets up my math that's going on. When I look at my second one, then I have 2 and it goes up to 44. So that would be in the 2 for my independent variable and 44 for my dependent variable. And the last one is at 3 and 46. So I know that my independent variable is 3 and my dependent variable, my answer to whatever math I'm doing, is going to be 46. As I look at those, I want to find my pattern, right? I want to find my sequence as we looked in our previous lesson. When it comes to my sequence and what my pattern is, I'm increasing by a specific number. And when I see that I'm going from 42 to 44 to 46, hopefully I know that I'm increasing by 2 each year. But are we adding 2 or are we multiplying by 2? So when I start thinking about, well, if I take and I add 2, 2 plus 1 equals 3, well, that's not going to give me the right answer, right? What about 2 times 1? Does that equal 2? And it does. But we then had to start with something. So what did we start with? All right, so if I know that I'm going to multiply 1, or my independent variable, by 2, I have to add something else to it to get the 42. And therefore, when I start looking at what I'm doing, I have to add 40 each and every step. Because when I start plugging it in, and if I look at what my expression would be, or my equation would be, it would be 2 times my g, my independent variable, plus 40. So 2 times 1 is 2, plus 40 is 42. 2 times 2 is 4, plus 40 is 44. 2 times 3 is 6, plus 40 is 46. So that lets me know that the h is equal to 2g plus 40. It's going to be my pattern that I follow. Let's look at this one then. When I do the check, I'm going to follow the same pathway. It says to write an equation from the graph that could be used to find the total inches of snow equivalent to any number of inches of rain. So what I can see when I'm looking at my graph then is that I have inches of rain, and that's going to be my independent variable. And then my outcome, my dependent variable, is going to be my snowfall in inches. So rain is going to go across the bottom, where snowfall is going to go up. So I have my X going across the bottom, my Y going up in snowfall. And as I look at that increase, I can see that I have in my ordered pairs, then I would go over 1 and up to 10. Once again, I'm just running and then jumping. So I run forward to the 1 and I jump up to my point and I see that that's a 10. If I go back to 0, 0 for my second point, I'm going to run forward to the 2, and this time I'm going to jump up to 20. So my ordered pair is 2 and 20. So then I just want to start transferring that information over into my independent and my dependent columns. And as long as I'm following my ordered pairs, they let me plug them in rather easily. So if I have 220 for an ordered pair, my independent is 2, my dependent is 20. My third point, I'm running forward to the 3 and jumping up to 30. So therefore, if my ordered pair is 330, then my independent is 3, my dependent is 30. And then I do the same thing for 4. I run forward to the 4, I jump up, and it's to a 40. So that's going to be my next set in my columns. So what am I doing each and every time? That's what the question becomes, because once again, I'm being asked to write an equation about this graph. So my pattern each and every time is increasing by 10. Am I adding 10 or am I multiplying by 10? Well, that's where I have to start asking. If I take 10 plus 1, well, that gives me 11, and that doesn't work, right? Or if I take 10 plus 2, that gives me 12, and that doesn't work. So therefore, I know I'm not adding. So if I check my multiplying, and I take 10 times 1, which is my independent variable, I do get that dependent variable of 10. And if I take 10 times 2, I do get that dependent variable of 20. And 3 times 10, 4 times 10, those all check. So I know what I'm doing mathematically is taking my independent variable, which is going to be an R in this case, and multiplying it by 10. And then that will give me my outcome. So what we are saying is for every 10 inches of rain, however many inches of rain I get, right, or excuse me, for every inch of rain, no matter how many inches of rain I get, I'm going to end up with 10 times that amount in inches of snow. So I can write my equation either as 10R equals S or 10 times R equals S, because they're both the same answer. All right, so it's just taking the information and either being able to plot it on the graph or going from the graph and creating my equation. All right, so it's a quick lesson. It's still less than 30 minutes, plenty of time in class to get all of your notes and pay attention, write it down and learn it, rewatch it if you need to, ask questions. You have 5 questions, 2 through 10, which are your evens.